The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Warren, we'll turn things over to you, and we're going to hear some discussion about designing mixtures to meet the requirements of the specifier and the installer, a topic that is very dear to my heart as well.
Perfect. Good morning, everybody. My talk is going to be a little less technical than some that you will hear today. I come from more of the practical side of the industry. Started out as a finisher many years ago, and learned very quickly that that was awfully hard work, and I decided that I would get into another facet of the business. But having said that, I want to talk about a job we did in 2011, 2012 in Ann Arbor, Michigan, called the Library Lane Underground Parking Garage. It was significant in a lot of ways. Number one, I think everybody's heard of how wonderful the economy is in Michigan. So to have a 55,000 cubic yard high performance job is a big deal. And I had the opportunity to work with some really good people along the way. It was one of the feature articles in October of Concrete International, co-sponsored by Gail Vasanas, Chief Structural Engineer with Carl Walker Inc., and Doug Peters, Vice President of Operations of Chrisman Constructors, who actually placed and finished all the concrete. A quick thank you to the team, and it was a team effort. It was one of those jobs that we thought was never going to start, which actually worked to our benefit because we were able to do all our homework, and by the time we got ready to place concrete, we pretty much had all the answers to the questions. So to Carl Walker Inc., Chrisman Construction, who was a CMs on the job, Chrisman Constructors, who were the ones that actually placed and finished the concrete, and then of course our good friends Doan Ready Mix, who supplied all the concrete and actually gave us the opportunity to do what we did with the mixes. Not always are ready-mix producers willing to allow admixture people, if you will, or cement people for that matter, because we brought the cement manufacturers, QC manager into this also in the early phases of it. But a thank you to everybody. Like I said, it was a 55,000 yard job, high strength, low shrinkage. It was interesting. We did this talk for the Carl Walker people down in Kalamazoo, Michigan, and they broadcast it to all their locations across the country. And it was interesting. Gail Vasana said to me, "Is our specification too tough?" And if anybody has ever worked with them, their specification is quite tough. But I told him the type of work that you actually do, it was very appropriate. But they were very good to work with. There were more RFIs before we ever started designing the mix than probably 10 other jobs put together. This is a rendering of the finished product. Actually, this is the finished product as we see it today. The foundation was designed to ultimately handle a 16 to 18 story high-rise building. They're fighting in Ann Arbor, Michigan right now as to whether that's going to happen, but hopefully someday it will. This is another picture of it looking down in the very beginnings of the job. And then you can look here, the north is up here, we've got the west over here, the east and the south. Everything concrete-wise was staged from this street over here. It was a logistical nightmare, but actually turned out pretty well, all things considered. What an engineer wants and what a contractor needs are not always one and the same. And our goal for this job was to not only satisfy Carl Walker, but also to satisfy Chrisman Constructors. In the article, in my portion, I asked the question, is it possible to design a perfect mix design? By the time I get done here, I hope you will agree with me that the answer is yes. The title was Challenges of Design and Constructability. It probably should have been more like Challenges of Design versus Constructability, because engineers and contractors are not always on the same page at the same time. I'm going to discuss briefly the two main concretes in the project. We had a 20,000 yard mass mat placement, and it was interesting because they were back and forth on what type foundations they were going to use for quite some time, but what it did was bought us time to design our mixes, you know, take the time for all the shrinkage tests and so on and so forth. So it worked sort of to our advantage, and at the end, when they decided that they were going to do a thick mat foundation, of course, the ready-mix producer, myself, and my cohort, Tony Candeloro, I think we went out and had a beer because that was another 20,000 yards that was going to be placed on that project. The other concrete, and the one that is the one that was the tricky concrete, was for the 6,000 psi post-tension decks, Aaron trained. Briefly on the mass concrete, as so many specifications say, maximum concrete temperature placement 70 degrees. This can be a huge problem, and in my opinion, unless you're designing mixes that have boulder size aggregates and you have cooling coils in the concrete, you can't always do what we would like to do with mass concrete. If you prescribe, as I do, if you can't keep it cool, keep it warm theory with mass concrete, then all of a sudden that maximum concrete temperature at placement is not the key number that we're looking for. What we're looking for is what is our ultimate temperature, internal temperature that concrete going to be. So as a team, we agreed to forego the 70 degrees, and let me back up 1 second. When this was all going on, originally the mat placements were going to be done in the summertime. So that made this 70 degrees maximum temp even more critical. Anyway, as a team, we agreed that that wasn't the number to focus on, that 160 degrees, which is pretty much accepted in the industry, internal temperature was the maximum temperature that we could wind up with, and that we would focus on the differential between the internal temperature and the temperature at the outside of the concrete, and that's our delta T. Again, we agreed on the maximum 160 degrees. Our maximum delta T was 35 degrees. There are some now that say this was a limestone mix. There are some now that say you can go to 45 and 50, but we stayed on the conservative side. And so our maximum internal versus external temperature had to be maintained at no greater than 35 degrees Fahrenheit. This this is what the mix looked like. We were making 5,500 PSI concrete, but our total cementitious was 517, type 1. We had 50% cement, and then 25% slag cement, and 25% type C fly ash. We had a traditional mid-range water reducer in that mix, and we were able to attain a 0.49 water cement ratio. Our calculated adiabatic temperature rise was 67 degrees. So what that told us is that as long as we didn't exceed 90 degrees plus or minus with our initial concrete temperature, we would not go beyond that 160 degrees. We did a mock-up, a 10-foot by 10-foot by 10-foot mock-up with thermocouples, protected it, did all the things we would do when we got ready to place the concrete in. We were, in fact, able to determine that we were not going to exceed that 160-degree maximum internal temperature. Well, as a lot of jobs go, the job that was supposed to go in the summer actually went mostly in the winter for the mass concrete. Now we were not concerned about, our maximum temperature, but actually what is our minimum temperature going to be. That was pretty easy to take care of, but for those of you that have prescribed to the, if you can't keep it cool, keep it warm theory, maintaining that 35-degree delta T in the wintertime is much more difficult than it is in the summertime, because in the summer you've got the ambient temperature working in your favor, whereas in the wintertime you've got it working against you. So the contractor had a lot of experience with mass concrete, and they placed down 2-inch rigid insulation, then with concrete blankets over the top of the mass placements, and everything went quite well. The largest placement was 5,700 cubic yards of the 20,000, and it was noteworthy because for those of you that don't live in the North Country, in Michigan we have something that's referred to as frost laws. And what that means when the frost laws go on, and that's sometime prior to spring, and this year who knows what date that was, but the frost laws have been on since February 1st. What that means to a contractor and a ready-mix producer is that instead of placing hauling 10 yards of concrete, now you can only haul about 4. Well, how in the world are you going to place 5,700 cubic yards at 4 yards at a crack in an urban setting? Obviously, this wasn't going to happen. So the powers to be in the city of Ann Arbor forewent the frost laws, and also the street that we had to work off of was a one-way street going northbound, and they had to change the direction of the street to allow the trucks to come in southbound. So it was more of a logistical problem than it was concrete, because mass concrete is pretty easy. In any event, 5,700 yards, stone concrete, drivers drove the first 14 hours, and then their crosstown competitor actually agreed to supply drivers to drive the next 12 to 14 hours. Well, they get over there, and as things happen, they had forgotten their proof of insurance. So now all of a sudden they're at a dead standstill after 14 hours of placement. Well, the resolution was, and you got to give credit to the crosstown competitor, because they actually allowed their drivers to drive Doan's trucks throughout the night. So the drivers got time off, but the trucks never did. So anyway, it was a nice pour. This gives you an idea. Up here at the top, they took the boom off of one of the pumps that was on Division Street and put it on a pedestal. And then we had a spider here also that can revolve 360 degrees. And this was the placing method. The 5,700 yards doesn't sound like a lot, and I was involved with the placement at Metro Airport some years ago, Detroit Metro Airport, where we did 21,000 yards in 23 hours. And I think that may still be record in the United States. But that was a particular situation. You know, we had not only the urban setting, but we only had one place for 2 pumps to be located. So logistically, it was a very tough pour. Okay, I'm gonna move on to what I really want to talk about now, and that's the designer's needs for the post-tension slabs. In this case, it was 6,000 psi air and train concrete. That becomes significant in a moment. I'll show you. Water cement ratio of 0.40. Maximum shrinkage at 28 days of 0.036. Water soluble chlorides 0.06 for post-tension decks. Here's the kicker. 4.5 gallons of a corrosion inhibitor that contained 30% calcium nitrite. For those of you that have worked with corrosion inhibitor like this, they're very good corrosion inhibitors, but they're also wonderful accelerators. 4.5 gallons is a large dose. Typically you see 3, maybe 4, but 3 primarily, and this wound up being 4.5 gallons. Lots of testing on this job. Every load of concrete was checked for air. Every load. Microwave testing, our wonderful friend the microwave. In the Midwest, we're not real comfortable with the microwave. I know on the East Coast it's you know, an everyday occurrence, but we haven't had a lot of success. I'll be quite honest with you. Our first pour, our first mass pour, was a 1,500-yard placement, and they started getting water cement ratios from the microwave of 0.67 when we're looking for a 0.49. Well, the concrete was too beautiful, and everybody agreed, we'll figure out what's wrong later. We even actually went to the extent of pulling more water out and putting more mid-range in, and our water cement ratio, according to the testers, went up. So we knew there was something wrong. As it turned out, it was simple calculations, and after that, everything went well. But they did cylinders at 50 to 100 yards. It was a very highly tested job. They actually did hardened air, and luckily where they cored, our hardened air parameters were perfect. So we got lucky there. Those were the designer's needs. Now the contractor's needs. They needed obviously a constant flow of concrete. They needed a ready mix producer that was going to get concrete to them at all times, nonstop, to keep the flow of concrete going. And that can be in an urban situation. That can be a challenge in itself. The concrete had to be pumped a city block in most cases, because like I showed you, we were stationed at the east end of the project and had 2 pumps there on a residential street, and that's where everything happened from. We obviously, since they were testing the concrete, we needed consistent air and slump. The concrete obviously needed excellent consolidating properties because of the post-tensioning tendons, and also the reinforcement in the columns as they were placing the concrete had to be you know, easily consolidated. It had to be easily placed and broomed, and this was more of a situation in the warm weather because the contractor was actually doing a job in another city at the same time, and excuse me just a second. Was doing a similar job in another city, and they were having all kinds of problems. They were having to pour at 3 and 4 o'clock in the morning and still weren't having a whole lot of success. So, of course, the pressure is on us to design something that is going to work a whole lot better than that. So it had to be something that was easily placed and finished. They needed predictable setting times. The mix had to perform in both hot and cold weather, because we did We did as much concrete in the wintertime as we did the summer. And after all these things that they needed rapid strength gain for post-tensioning purposes. They wanted to be able to post-tension in 24 to 48 hours maximum, winter or summer. The challenges, obviously, to meet Carl Walker's specifications, which were numerous, and also to manipulate the concrete so it acted like 70-degree concrete on a 70-degree day. And that was really the challenge. Whenever you see a specification that calls out for a water-cement ratio of 0.40 or less, the first thing that comes to mind for someone designing concrete is the use of a high-range water reducer. And for structural concrete, I agree wholeheartedly, but like I mentioned, I started my career as a finisher, and I tend to look at the concrete more through the eyes of the flat work contractor, and a high-range water reducer may or may not be suitable for finishing of concrete. And the real challenge, besides the everything else in the specification, the spec called for 4 gallons of the corrosion inhibitor. Because of the water-soluble chlorides of the concrete we produce, we had to add an additional ½ gallon to compensate for being over a little bit. So we wound up with the 4.5 gallons. And did I mention the concrete was air trained? And Carl Walker is a stickler for wanting their air being perfect. What were the solutions? Well, first we determined how much cementitious, and really I should say how little cementitious, we could use to make 6,000 psi air trained concrete. What was I going to say? If you use too much cementitious material, that drives your water-cement ratio up, that drives your shrinkage up, it drives a lot of things up. So the goal was to use as little cementitious as possible, but still make our 6,000 psi at 28 days. But on the other side of the coin, we had the contractor that wanted to be able to post tension in 24 to 48 hours. So it's one of those, they wanted their cake and eat it too. After analyzing the amount of fly ash, the amount of slag that Carl Walker would allow us to use, we determined the amount of cementitious material we wanted to use, and we started looking at what do we need to manipulate this concrete so it's going to set. We've already satisfied Carl Walker's needs. Now we got to satisfy the contractor's needs. So we set out to manipulate the set of the concrete with the use of admixtures. And again, our goal, whether it was winter or summer, was to create concrete that sat like it was 70 degrees on a 70-degree day. This is what our mix looked like. 641 pounds total cementitious. 60% fly ash, 15% slag, 25% fly ash, 60% cement, I'm sorry. And this was all, the 15 and 25% was set in stone by the specification, so we couldn't go up or down on those. We did use a crushed 1-inch limestone. We took a page out of Bill Phelan's Athletic Concrete book and tried to maximize our coarse aggregate, knowing that we had to pump this concrete a city block, so we did have restrictions in that regard. The mix, as I mentioned, has 4.5 gallons of corrosion inhibitor. We had 223 pounds of water, which is a 0.40 water-cement ratio. And this is where it got fun. We wound up using 6 ounces of what I'll refer to as a hybrid mid-range. It's a lignin-based product with a splash of polycarboxylate and a defoamer. And then we used 5 ounces of a traditional lignin-based water reducer, knowing we got decent water reduction with this combination, but we knew we were getting quite a bit of retardation, but that was our goal. Our goal was to offset the acceleration of the corrosion inhibitor. The combination of admixtures that we used gave us approximately 20% true water reduction. So we did get into that high range category, but we just didn't use a high range in order to do that. The combination of admixtures and the supplemental cementitious materials allowed us to overcome the acceleration of the 4.5 gallons of corrosion inhibitor. We did testing. The concrete contractor thought we needed more mix in the water, water in the mix in order for his finishers to have time to place and finish the concrete. So we did a test pour to accomplish a couple of things. We redesigned the mix, added water, which also meant we had to add cementitious material. We placed that mix, we placed our mix, and we let the finishers decide who was going to, which concrete they wanted to use. And we also used this as our example for the owner to decide what type broom finish, because, you know, there's a multitude of broom finishes out there, so we were able to determine which broom finish the owners wanted. As it turned out, the finishers chose the mix that we had already put together and had tested, thank goodness. I don't know what we'd have done if they'd gone the opposite direction. We'd have had to start over, but again, a lot of testing. These are some actual results in excess of 8,000 PSI. Shrinkage at 28 days, 0.031, so excellent shrinkage numbers. This is just kind of a shot of how the placements did not go fast. In the wintertime, no big deal, but if this mix not be as workable and usable as it was, it could have been a problem like they were having on a job across the state. The interesting thing about this concrete, it outperformed my expectations in a couple of ways, but it did not bleed. This concrete never bled. In the wintertime, that was great because we didn't have to worry about bleed water freezing. But in the summertime, I was concerned that we wouldn't have enough lubrication in order for the finishers to do what they needed to do. It did not turn out to be the case. We placed the concrete at, typically it was in the 7 to 8 inch range. We were losing virtually nothing through the 600 feet of pump line, and we weren't losing a 0.5% air as well. These are just nice pictures. We all like nice concrete pictures, I think, in this room. This was what a typical deck pour looked before we started placing concrete. You see all the blue tendons, all the steel in the concrete. In order for this job to work, there was significant pre-planning on the part of the ready-mix producer, ourselves, and the cement supplier. And our goal was to satisfy the engineer and the contractor. Is Doug Peters in the room? I guess not. He's a VP of operations for Chrisman Constructors, and he's a good concrete guy, tough concrete guy. And at the end of the day, you can read the other verbiage, but this mix design performed better than any previous PT mix in his career. So that was a real testament to the fact that we had accomplished our goal. You know, the teamwork, attention to detail, pre-planning, coordination, it all spelled success. And to answer the question, can you design a perfect mix design? After this job, the answer is definitely yes. Thank you. Any questions?
Terrific. Thank you very much. Very interesting presentation.
Thank you.
Terrific. Our next speaker is